1.
No, 6 minus 1
1.
is 5. Greetings and welcome, friends. Today we are talking about, yes we are, the quadratic formula and the discriminant. Ooh. Now Now don't you go discriminating against the discriminant because it's got a name like that and assuming that it's a bad thing. Maybe the discriminant is an excellent, wonderful technique in mathematics to do great and amazing things. So watch yourself. Come on now, really. So we're going to start off today deriving the quadratic formula. You could even say discovering if you wanted to. Discovery. And so for this discovery, I've got this premise. Imagine a quadratic equation, just a plain old generico quadratic equation of the form ax squared plus bx plus c. Right? We've seen those before. And let's say I want to complete the square in that generic form. So that's what I'm going to do here.
What is this?
You don't have to write this down, considering the fact that I'm just explaining this to us. No. So this is the idea. So check this out. We have this guy right here, and what I'm going to do is complete the square. So what's the first thing I got to do? Let's move the old c. Right, so I move the old c. Next thing I'm going to do, oh man, I don't like this a here, so I'm going to divide everybody by a. So that's what I go through, divide by a's, right? Bam, and this is what I get. Bam, and now hey, I've got this nice little blank line. I'd probably even throw another blank line over there. And well, I've got to complete the square first. How do I find out what goes there? Well, I'd do the b over 2 all squared. So that's b over a all over 2 all squared in this case. And Al-Mali, what's a way I could deal with this a and 2 thing?
You just divide, multiply them.
Multiply them. So this is the same as b over 2a all squared. And b over 2a all squared, if I distribute that square, is b squared 4 and a squared. And that's what I happen to have right here. Okay, now I'd be on the fast factoring step, the fast track to success. So that's what I did. I fast factored this, of course. This value comes from a few locations. It comes from this right here. I could have gotten that from halving the b term. I could have gotten that from square rooting this and taking the sign from the b term. Right, so lots of possibilities for that fast factory. And over here, I had to find a common denominator because a and 4a squared they're not like terms. In order to do that, I had to multiply this by 4a over 4a because 4a times a is 4a squared. And then I was able to combine those with some frac magic, mathemagic, right? And now what would I do? I'd root both sides, plus or minus. I'd never forget. I'd never forget you. Look at that little cute little plus or minus. So adorable. Rooting both sides would have canceled out with the square, leaving me just this guy here. And notice how cool this is. This radical technically is applied to both the numerator and the denominator. And the square root of the top, I'm going to leave like that for now. But the square root of 4a squared, the square root of 4 is 2, the square root of a squared is a. Right? And question, why don't I take the square root and distribute it like that?
It's already in square root, so you can't.
But like take this square root and just like break it over the...
It's over subtraction.
Because it's over subtraction. Good call, my friend. Because you can't distribute exponents over addition or subtraction. Similarly, you can't do that with radicals either. Because you might recall that radicals are in fact just fractional exponents. So their nature behaves very similarly. And then looks like I would subtract b over 2a from both sides, right, to try to get x by itself. So subtract b over 2a, both sides. And then I was like, wait a minute, these guys, they done diddly have the same denominator, is what I might say. And you're correct, my friends, they do have the same denominator. So I could combine those over a single denominator, and behold, what do I get? Ravioli, ravioli, give me the formuoli. This is what we get right here, the quadratic formula. The math reveals it. It says, watch, follow along. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
You just like got like 5 different personalities in that.
Oh yeah, that was an amazing song though. And so we have discovered the quadratic formuloni. How great is that? That's wonderful stuff. So if you want to write this down, here's a little thing about the quadratic formula. It says the quadratic formula is used for basically finding the solutions to the quadratic equation of this form. All right, so when I'm talking A's, B's, and C's, it's this A, it's this B, and this C, right? So that's what's up. And in that quadratic, right, it's set equal to 0. If it was factorable, I would have solved it by factoring. If I wanted, I could solve it by completing the square. Or with a formula, I could tell you what x equals if I just do a little plug and chug. Just plug in the values for A, B's, and C's, and then chug out the PEMDAS order of operations. You know what's up. That's what's up. So that is a possibility. You can drown, or there's actually also water poisoning.
It's actually called water poisoning. You can do it if you take ecstasy because you get really thirsty.
Oh, I didn't realize that was a problem in here.
No, I don't take ecstasy. I'm saying if you do, you can.
Oh, so yeah, so those of you watching, pro tip, go check out Emily's channel about how to do drugs safely, apparently. No, I'm not going to promote that channel, please. The terrible, oh my goodness.
Check out mine.
So here we go. We've got an example coming at you. It says solve using the quad formula. So quadratic formula only works in certain situations, specifically when it's quadratic and when it's equal to 0.
Well, that's not equal to 0. Oh, so we have to make this equal to 0.
How do I do that?
By plussing and adding, by subtracting 30 to both sides.
I like that.
Same.
One less 30-year-old in school. That's what it'll be when I leave.
Actually, that's illegal.
Well, I'm 30 years old, and I would not be here, and I'd be gone. Wow, how sad. So I subtracted 30 from both sides, and hey, what do you know? Also, good pro tip.
All 3 of those can be divided by 2.
Yeah. I mean, I could do the math with A equals 2, B equals 4, C equals negative 30, but who wants to use big numbers when you can use small numbers? So let's div everybody by 2.
X squared plus 2x minus 15 equals 0.
Oh, you figured out that 0 divided by 2 there? Ooh. Yeah, there we go. And now that I've got this not only in standard form, but even simplified a little bit, what are my A's, my B's, and my C's? Tell me, El Molly.
1.
Yeah?
That's going to be 2. B is 2.
Yeah, it was just like a sloppy B there. It was trying to figure itself out.
15.
Perfect. I love it. So now that I know A, B, and C, I can just plug these straight into the formuoli.
I like the quadratic form.
So here we go. Ready? X equals the opposite of 2 plus or minus the square root of 2 squared minus 4, 1, negative 15, all over 2, 1. There we go. Wow, that one was pretty good. I'm proud of how that came out. So, points to point out here, the best kind. This radical, make sure your radical vinculum here, this top part, covers the entire b squared minus 4ac. Sometimes people like just make it shorter and then they just like square root a square and then the formula's wrong. So that's no good. Also, the fraction bar. Sometimes people make it too short and then like this -2 is just like out front, and then it's like a fraction over here, and that's wrong. Other people get so excited about the all over 2a that they somehow like include the x equals in the numerator. I don't even know what that means. What's an equal sign doing in the numerator? What? I don't know. Oh my goodness. So I plug it in all very oh so carefully. Notice I even used parentheses when I substituted those values, just to be careful with my minus signs when possible. So x equals -2 plus, oh, I forgot my minus. Oh, guys, I thought I was never going to forget. I forgot. It was that easy. 2 squared is 4. Negative and negative is positive, and 4 times 1 is 4 times 15 is 60. All over dose. And x equals -2 plus or minus the square root of 64 all over 2. So square root of 64, hey, that's lovely, it worked out. -2 plus or minus 8 all over 2. And so now I could kind of break this into two situations here. Either x was equal to -2 plus 8, which is 6 over 2, or x is equal to -2 minus 8, which is -10 over 2. Wow, hostility. So x is equal to 3 or -5.
I apologize if you have friends and hostility is not meant for you.
Oh, okay. All right. I haven't seen such hostility since the year 1849. Did you know Abraham Lincoln patented a new buoying system in the year 1849? It's true. Abraham Lincoln, not bad. Buoying, B-O-U-Y-ing. Apparently he was like into ships or something. I don't know. So that's using the quadratic formula to solve that. That's not that bad. You've seen that before, but what you haven't seen is what you're afraid to make conclusions about, is the discriminant. And this guy, my friends, is excellent. The discriminant. D for the discriminant is equal to b squared minus 4ac. Wait a minute. B squared minus 4ac. I believe I've seen that before. This is familiar. Where did we see that before?
Ew, you sounded like what's inside of the one.
Let's see what's inside. This part right here is called the radicand of the quadratic formula, right? That was the inside of the square root, like we were just saying, right? It's radicand. So the discriminant is literally just that inside value, and it turns out I've got this nice little chart where what I use D for, what I use this discriminant for, is really like a measurement tool to determine what are things going to look like when I end up getting these answers. What's going to happen when I solve this? It's a litmus test. It's like, what category type of problem is this going to become? And I've got this nice little chart here for us.
Okay, time to write down.
So think about this. Now remember, the value of D is the radicand of the quadratic formula. So it's a number that is inside of a square root symbol. So there's some restrictions on what happens inside of a square root. And as a result, I can determine the nature of the roots is what that says there. That's roots is another word for, let's see, we have some synonyms for it. X-intercepts. We could refer to those as solutions. We could refer to those as zeros, Z-E-R-O-S. Or, I think if you're like British, maybe like that, which is pretty cool, maybe. But, so the value of D will tell me about the nature of the roots, what they behave like, what kind of problem this can be categorized into. So that's why it's called the discriminant. It allows me to kind of group things into categories and discriminate them from one another, sort of. So it's good when it's numbers. Okay. So so if D is positive, all right, the square root of a positive number, there are two numbers that come from that, right? The square root of 4 is both 2 and negative 2. The square root of 16 is both 4 and negative 4. So the square root of a positive number is going to give me two real solutions. That plus or minus is going to have that effect on us. So right there, that's good stuff. Two real solutions. And not only that, if it's a perfect square, so if D is equal to 64 or 121 or 256 or 1024 or not
4.
or 4, there we go. Then it tells me that my answers are in fact going to be rational numbers. So notice, let me rewind. There we go. Notice what happens to the discriminant over here. The discriminant was the 64. Notice 64 is both positive and a perfect square. And what did I get? I got two solutions, and they're both real, and they're both rational. They could have been written as fractions. And even if, say, this fraction didn't simplify, it still would have been rational.
And the original problem is factorable.
And it also would have told me that the original problem is factorable, right? Because I could have found the factors of 15 that subtract to 2 happens to be 3 and 5. So the discriminant also carries that information with it. So if D is just plain old positive but not a perfect square, it tells me that I have two solutions, but they're irrational. Craziness. So, if it's irrational, that means it's like the square root of 3, and I can't break that down. So that means the entire set of answers are both also irrational. If D is equal to 0, what's the square root of 0? 0. What happens when I plus or minus 0 to something?
Nothing.
Nothing, and not only does nothing happen once, it happens twice. So my two solutions are now the same solution, and they're just one solution. But it's still real. And if D is negative, the square root of a negative number, that's done telling me there's no real solution to this. There are no real x-intercepts going on. However, if you want to be fancy, you could say that there are two imaginary solutions.
So would you still solve it, or if there was, if the D was negative, would you just
Yeah.
make a
It depends on the situation. If I'm looking for x-intercepts, I'd probably just be like, whatever. But if I was solving an algebraic problem, I'd be, oh, tell me about these eyes I need to know more about. And that's, I just want to look into this problem's eyes is kind of what I'd want to do for a while, and just be like, wow,
Smells like food
this is
out there.
imaginary. Smells like food. Boy. So let's do 2 examples, and we'll call it enough on the discriminant. So let's. It says determine the nature of the roots. This is the classic set of instructions. That's basically saying, tell me what kind of answers this has. So that's not asking me to solve it. Just saying, tell me what they're like.
There's one real solution.
So D is equal to B squared minus 4AC, right? What are A, B, and C in this problem? A is equal to 1.
B is negative 8. And C is 16.
Yep. So let's just plug it in and find out what the discriminant is. So B squared negative 8 all squared minus 4 times 1 times 16. There we are. And so negative 8 squared is positive 64 minus 64 equals 0. Uh-oh. The discriminant did equals 0. So what does that mean?
One real solution.
One real solution. So one real solution is the idea. So it didn't ask me to tell you what the solution was, but just with that little litmus test, I was able to check the oil of the car sort of thing, take the dipstick out and check it, and oh, this oil's kind of black and there's not enough of it. your car probably needs an oil change and some oil soon, right? It's just telling me about the problem. You know, it's like what kind of things going on there. So let's do one more and another discriminant. And here we go. So determine the nature of the roots. So A, B, C. Also, sometimes people are like, we'll just, instead of doing A equals something, they'll just say A and then like point at this. Don't do that. Don't do that. You got to tell me for reals what A is. Because if you point at this, is A the X? Is A the X squared? Is A the 2X? Is it the 2X squared? Is it the 2? I need to know. And sometimes people actually get that part wrong. So for reals, just tell me A equals 2, B equals, and then if you like point it here, is it the X? Is it the 9X? Is it the 9? Is it the negative 9X? Is it the negative 9? There's actually a lot of information that is lost with just a little arrow like that. And C is equal to 8. So, plug it in, negative 9 all squared.
Plug it in.
Yeah, that still exists. It still exists. D is equal to 81. I think he's just trying to get his foot in the door on YouTube for like the cool singing song stuff that I was doing, trying to compete, steal my likes. So 81 minus 64, 11 plus 6, 17.
Where did that even come from?
It was a cent
It's
thing.
Blake.
Yeah, there you go.
Oh, okay.
So D equals 17.
That means 2 real solutions.
So there are 2 real solutions. Yeah. You could also tell me what kind of solutions are
They
they?
would be rational numbers. And not going to be
Irrational.
what they say.
You can't talk any sense into them.
That's what I said.
Yeah.
Irrational.
Oh, I don't know. Well, it's close enough. And actually, I saw a comic the other day of I think it was like 4 and Pi were at marriage counseling, and 4's complaining about Pi, and just like, man, my wife is just so irrational. She just goes on and on and on forever. And it's just, come on.
Wait, what was that?
It's just some comic. So D equals 17. So not only are there 2 real solutions and it's irrational, it also tells me that this problem is not factorable. So don't even bother multiplying A and C like that. So thanks for watching, friends. Have a great day. Also, song credits going out for the song regarding quadratic formula. That's the tune of Pop Goes the Weasel.